Okay, so we're going to talk about predicting if a solid will form. And we're going to do that by comparing the KSP to the QSP, or sometimes the QSP will be called the QC. This is the same as when we talked about Q, the reaction quotient. Back when we started talking about equilibrium. So remember, the reaction quotient is the same setup as the equilibrium expression, except it's at any point that is not equilibrium. So the setup is still the same. Q equals the concentration of products over the concentration of reactants. It is at some position that is not equilibrium. That's the difference between Q and K. And the other things still apply. So coefficients become exponents, and pure substances are excluded. So solids and liquids still excluded. So the way that we are going to use this is that if Q, we'll say QSP, if QSP is greater than the KSP, then that means this reaction is going to favor the reactants. If the QSP is less than the KSP, then that means this reaction will proceed to the products. So when we think about this generic reaction that we have, so we have this slightly soluble, insoluble salt. So if we have this situation where the QSP is greater than the KSP, that means it's going to favor the reactants. It's going to favor a solid. So in this case, we would show that a precipitate, which is just another word for solid, will form. If the opposite is true, if the QSP is less than the KSP, it's going to favor the products. The products are aqueous. So this would be an aqueous solution, no precipitate, no solid will form. So the way that a lot of these problems will read is it will give you values to solve for QSP, to compare QSP to KSP, and then to predict whether something will precipitate or not. And remember, precipitate, PPT, just means that a solid will form. So if QSP is greater than KSP, that means this reaction is going to shift to the reactants. The reactant side of this reaction is where the solid is formed. So that's what we are understanding from comparing the reaction quotient to the solubility product constant. So let's look at an example. Okay, so here is an example. It says exactly 0.400 liters of a 0.500 molar lead-2 ion and 1.60 liters of a 2.50 times 10 to the negative 2 molar chloride ion solution are mixed together. When they're mixed together, 0.4 liters and 1.6 liters form 2 liters of solution. So it says calculate the QC of lead-2 chloride and determine if lead-2 chloride will precipitate. QC, QSP, you might see them used interchangeably. Calculate the QC of lead-2 chloride and predict if lead 2 chloride will precipitate. And then you also are provided the KSP of lead 2 chloride, which is 1.6 times 10 to the negative 5. So what we have is conditions not at equilibrium. We're going to solve for the QSP or the QC and compare it to the KSP. Okay, so we have to do a little bit of dilution here because we have two solutions and we're combining them together. So let's see with the lead. I have 0.4 liters of the lead 2 ion. My new volume is going to be 2 liters because it's 0.4 liters plus 1.6 liters. So I'm just going to say for the lead 2 concentration, remember it's M1V1 equals M2V2, and what I'm solving for is M2. Remember V2 for both is 2.00 liters, okay? So I'm going to say M1, the initial volume, the initial molarity, 0.500 molar, times V1, 0.400 liters, and I'm going to divide it by the final volume, which is 2 liters, 2.00 liters, and my new molarity is going to be 0.100 molar. That's my molarity of the lead 2 ion. Let's do the same thing with the chloride ion. Again, the final volume, V2, is 2.00 liters because it's just the sum of these two volumes. So I'm going to say chloride ion, M1V1 equals M2V2. Again, I'm solving for M2. So it's going to be 2.50 times 10 to the negative 2 molar times the volume, 1.60 liters. I'm going to divide by the final volume, 2.00 liters. My M2 is going to be 0.0200 molar. So now I have my concentrations, and I can put this into my QSP expression. So let's write the equation. So here is my salt, PbCl2 solid. It's going to break apart into the lead 2 ion plus 2 of the chloride ions. So remember, the way that we write the expression is QC is the concentration of the products, Pb2 plus times Cl minus squared over the products, which is a pure substance, so we exclude it. So I'm just going to sub these in. So the concentration of my lead, the concentration of my chloride, I'm going to say QC equals 0.100 molar times 0.0200 molar. Remember, this one gets squared because I had 2. Remember, coefficients become exponents. So when I solve this, I get that the QC is 4.00 times 10 to the negative 5. So now I am going to compare the QC to the KSP. So the KSP is smaller, 1.6 times 10 to the negative 5 is smaller than the QSP or the QC, 4.00 times 10 to the negative 5. So QC is greater than KSP. That tells me the equilibrium, that this reaction is going to favor the reactants. That is a solid, so that means a precipitate will form. So this is how we use concentrations at positions other than equilibrium to determine if a solid or a precipitate is going to form. So you solve for the QC just like we've always done with any equilibrium expression. Compare the QC to the KSP. If the QC is greater, that means it favors the reactants. Remember, the reactants in these solubility equilibria are solids. So if it favors the reactants, a precipitant will form, precipitate. If the KSP is greater than the QSP or the QC, that means it favors the products. The products are aqueous, so there would be no precipitant.